Okay, today let us try to work on how to come up with exponential models, logarithmic models, logistic models, and for a given set of data using GeoGebra. Okay, here I have opened up GeoGebra, so you can just type in this website name, which is geogebra.org/calc. To work with spreadsheets in GeoGebra, you need to click on this 9 little buttons, okay, and go to GeoGebra Classic. Okay, click on that, and then you will be taken to a new web page, and there you can see at the center of the right hand side you can see spreadsheet. Okay, so click on that and you will be taken to this spreadsheet option. You need to type the data that has been given. Okay, so let's go to our book and try to see what's in there. Okay, so this way, so let me write down this as x. Okay, the first column is x and the second column is f of x, right? Okay, in first column we have 1, 2, 3, 4, 5, 6, and in the second column we have 555, 383, 307, 210, 158, 122. Okay, so that's fine. So after we have written down all of the data, okay, in this way, then the first thing that we need to do is we need to come up with scatter plot. Okay, let's come up with scatter plot. So to do that, first of all, we need to select the data that we have just written down. Okay, and then click on this bar-like object over here. Okay, and then you go for two variable regression analysis. Okay, go for that. Okay, once you go for that, the data points will be plotted automatically. So you can see that by the nature of this data points, you can either say this is an exponential curve. It looks like an exponential curve with negative power, right? Or you can even go for logarithmic function as well. Okay, this problem, what it has been saying is use a graphing calculator to create a scatter diagram. Okay, it is asking about finding out an exponential function with base e. Okay, so let's go for that. So let's go for exponential function with base e. All right, so here you have regression model. So if you click on this drop down menu, then you can see a lot of many regression models, just like linear, log, logarithmic model, polynomial, power functions, exponential functions, growth functions, trigonometric functions, and logistic function as well. Okay, so here the question is asking us for exponential function, so go for that. Then you can see the exponential function is modeling this data. Okay, and the given equation is 731.923 e to the power negative 0.032x. Okay, you can go for symbolic evaluation. Whenever x equals to something, the value of y would be given. So whenever x equals to, let's say, whenever x equals to 3.5, what happens? Okay, if you want to find that out, then you just write down 3.5 over here and then click on enter, then you'll get the value 253.3054. Whenever this kind of question is asked, just like in question number 35, use the intersect feature to find the value of x for which f of x equals to 250. Then you need to draw the figure. Okay, you need to draw the figure in GeoGebra. So let's do that and try to figure out what would be the corresponding x value for the functional value f of x equals to 250. So for that, what I will do is I will just pull this off. Okay, let me do that, and let me write down this equation. Okay, this equation is what? Okay. So this equation is 731 so this is y equals to 731.923 times e to the power negative 3032, okay, times x. All right, so that's our equation. So click on enter, then you will see the curve. Okay, so this is the curve. If you want to find what happens whenever x equals to 10, you just write down x equals to 10. Right, the corresponding y value would be this point, which is 35.29. That's fine. And now the question was asking whenever we have the functional value to be 250, what would be its corresponding value of x? So for that, since that's a y value, okay, you just write down y equals to, or the functional value equals to 250. Then you can see what's happening over there. Okay, this is somewhere over here. Then the curve is green. Okay, so you can see that for 250 the x value would be 3.5429. so if you write that down somewhere here, 3.54, then you can see it's nearly 250, right? So that's it. All right, so this is the way how you go for exponential model. Now I'm saying this again, this problem also can be modeled by using a logarithmic model. You just need to click on this drop down menu and choose the log function. Then you can see it is much more nicely modeled by this logarithmic equation, and the logarithmic equation is this one, 556.75 minus 244.02 times ln of x. Okay, so that's it. All right. Okay, so I hope this idea will help you to understand how you can go for exponential and logarithmic models. Okay, so that's fine. And another best thing to do is this GeoGebra right here in this spreadsheet, it doesn't let you work on finding out the corresponding x values for y values. So it's better to copy this equation in a different web page of GeoGebra and work that out the way that I have done. That's all for exponential and logarithmic equation. Now let me go for logistic equations. Okay, so logistic equation, let me find out a problem for that. Okay, so in this, for this table number 11, okay, from 46 to 50, you can see this is a logistic equation. Okay, so let me find out that. Okay, so here let me type the data. I mean, it is up till 10, so 6, 7, 8, 9, 10. Okay, so that's fine. So f of x 8.7, 12.3, 24.8. Once we have that, then the drill is same. You select this, okay, for which we want the logistic equation, and click on this bar like object, go for two variable regression analysis. Now you can see, okay, the log had been chosen over here from the previous problem, so that's fine. And you can see that the logarithmic equation also models this thing, but here we want logistic function to model this. Okay, so click on this drop down menu and go for logistic equation. You can go for any model you like. Okay, logistic equation. So you can see how it is going. Okay, so that's fine. All right, now you can clearly see, since we all know how the logistic equation or the logistic functions look like, okay, it's right here. And then now for our convenience, I'll copy this equation in next web page. Okay, so for that, okay, so that's fine. Okay, so here this is y equals to 25.0813 divided by 1 plus 3.1819 times e to the power negative 0.5453 times x. All right, so that looks fine. Okay, this looks good. Now you can clearly see what's happening over here. And okay, so let me just throw this thing away for now. Now you can see that this is a this is the logistic equation that you can see, logistic function, right? It is just like a S-shaped curve, right? It's like S-shaped curve, something just like S. And you definitely know what is the carrying capacity of this logistic equation, or what is the limit. Okay, now you can see that 25.0813 is the carrying capacity. To the nearest whole number, what is the predicted carrying capacity of this model? Okay, it's saying whole number, so you can go for 26 nearest whole number, and that should be the carrying capacity. Okay, that's fine. All right, and now it is saying we use the intersect feature to find the value of x for the model for which the model reaches half of its carrying capacity. The carrying capacity which we approximated was 26. Now why don't we go for y equals to 13, right? 13 is the half. Then you can see for 13, for the half of the carrying capacity, you can see 2.257. This is the way how you go for a logistic function, coming up with regression model for logistic equation.